Hello guys, this is Dr. Base from the Endless Fair Forum, and today it's time to take a look on the new Gaussmeter, which is a Tesla meter too. This is to test the magnetic field. I just received it in the mail today, and I will measure with you the actual magnetic field of this rotor coming from a QS 205 motor that I just finished repaired because it had a lot of rust on it, so I completely recovered it, complete full restoration, and including replacing Hall sensor. So I will open it and show you how it works and give you an idea on how much Gauss, which is the unit of magnetic field, how much Gauss I get with these magnets. Okay, so I will open it. I will say I paid it about $200 Canadian, so it look nice. Quality is, well, it look a little bit cheap, however it look quite accurate. I will compare it with a more professional one, but for $200 I guess it will do all what I need. It was displayed as one very accurate one, and double the price from all the average other Gauss meter. So just to let you know, it take 10,000 Gauss to give 1 Tesla. Okay, just to make you compare. So there's a connector here, and the probe is located here, and there's a protective cover, and they took time to indicate to pull the cover gently to not break the probe right here. So since I'm the cameraman and the guy that make the action, I will need to put you on the desk like this, just the time that I open it. Alright, wait a minute, it's a difficult job. Sorry for that. Okay, good. As you can see, I will remove, well, I'm not sure what direction the camera will take with the, okay, here is it. So that's the probe. It's this little chip here, and they put a black dot to indicate the position where the magnetic field is measured. Okay, and they also indicate a rule with a millimeter distance, probably to give you an idea of the magnetic field depending on the distance. So I will connect it and take the camera back in my hand to give you better better view. So I will just connect it this way. I remember this one is really fragile. In case you want to buy one, it's the TD8620, as you can see here. Okay, so I will just take the box away and take the camera back with me. Okay, so here's the probe and the meter. You can see it seems that it was built in April 2017, so it's recent, and probably this is for the calibration, which is still the same. So they took a sticker to indicate the fabrication and probably the calibration, which is good. Okay, and I guess the design is from 2016 or something like that. I don't understand Chinese language. Alright, so I will power it on. So it's in Tesla unit, and if I put it in Gauss unit, just like this. Alright, okay. And there's a bar graph to indicate when it will change the range, because the dot will change according to the range. Okay, so I will measure. I will indicate where I put it, and I will show you the data. So you see the magnet here. I will probably put it in the center of the magnet, as this is a location where the magnetic field is more uniform than on the edges where it's slightly more intense. But I guess on the middle it will be accurate, as it's a uniform and it's not only a very isolate maximum on the area of the surface. So as you can see here, it still measure 1.4 Gauss negative, depending on the orientation I put it. Probably the magnetic field of the Earth, not sure, but I will just null it. Okay, well, I don't care about 0.7 Tesla, as I will measure over 1000. So I will put it the place I indicate you, and you see it's increasing. So right in the middle I have about 3.3, well, 3,300. I changed from one magnet to another. It's about 3,200, 3,300. I will change the orientation. And yes, 3,300. I will change from one magnet to another. Still about 3,000. Okay. As you can see, I measured in both directions about 3,300 Gauss on these magnets. What you need to know is that these magnets have lost a bit of their volume because there was a lot of rust and they were damaged. You see, they are not perfectly flat. I just painted these as is, but they're damaged a little bit. Okay, this is brown paper on the back to avoid dust coming on it. And to give you a look on the stator, it was completely covered with rust, and all these slots here were full of rust dust, metallic particles. So with compressed air I removed all them, and also use a orbital sand machine to completely sand and recover to fresh metal all these surface, so it's nice and smooth. As you can see, you even have difficulty to see the lamination thickness. You can see a little bit. There's still little holes because the rust made that to the metal by corrosion. So yeah, you can see, and you can compare with a brand new stator here that was painted. There's line because the paint didn't go between the layers, but well, this is a brand new stator here that I recently painted, so they look pretty similar. This one looked more uniform because I've put more paint on this one. Okay, so thanks again guys for watching, and I hope you appreciated this video. Please don't hesitate to comment on the bottom, and see you next time. Bye bye.